spacing. Is there anywhere in the actual standards that gives us that tolerance of, I think it was like 1.2 to 1.5 or 1.5 to 2 meters, I think it is?
Yeah, but this not in standard. I think just this to limit the spacing between the Berlin, so you can use more Berlin to reduce the load transfer to the, or reduce the loads that go to the Berlin and then transfer the load to the rafter. So just a limit for the spacing. Not if you use higher spacing or larger spacing, this will cause like large section of Berlin. So that's why they give you a limit to reduce the size of Berlins.
Yeah, okay, because so I found it here. So the range, the span range is 1.25 to 2 meters.
Yeah. Because if you use higher, like larger spacing, like 3 meter or 4 meter, this will cause more load on the Berlins. And the Berlins is usually a small section of C section or Z section, and it is not designed to carry high loads or high moments. That's why they limit the spacing. So so you can find a good section or not cause more moment or more loads on the Berlins.
Okay.
So that the C section or Z section will be suitable to be used as Berlins.
Okay.
Yeah, but,
okay, that's all
but
good.
there is no statement or no clause in the standard to give you a limit for the Berlins. This is just from design experience.
Okay. Okay. No, that's good. That answers that. And then my other questions
are more.
How
do you mind if I can jump in, because I got like the same question just in terms of the Berlins?
Yeah, absolutely. Go for it.
Yeah. Hey, Ahmed. Just regarding the spacing and the number of Berlin, I'm just a bit confused how you found like the number of spacing in the example.
Yes. So I will share a screen with you so you can get it.
Yeah.
Okay.
So I think I asked you a question, but then I couldn't. Like I can work it out, like how they got it through the example, but in my assignment, I couldn't get the number to be exact. Okay,
I will. If this is the span we have,
yeah,
you can see the screen now.
Yeah.
If this is the span we have, like your span, let's say this 8 meter or 9 meter, whatever.
Yeah.
And this is our rafter. Okay. So you need to put Berlins in the longitudinal direction or in the other direction, like this. One here, one here. Whatever the arrangement. Right?
Yeah.
So those are our Berlins. And the spacing between the Berlins is something like this. You can choose to make all the spacing similar, X or whatever, or you can, like the example, I will work similar to the example. We have, let's say, X internal spacing, and at the edges, we have 0.75 spacing. Do you know why this spacing is only 0.75 or assumed to be smaller than the?
Because of the load, the outside load?
Yeah, because this Berlin, these two Berlins,
yeah,
are on the edge, so they are only carrying half load from the sheet or the slab, right? Because they have only one side of roof, yeah, right? But all the internal Berlin, these ones, carry half from the right and half from the left, so it carry more loads.
Yeah.
This is the idea why the spacing is smaller at the edges, and that's why also that can explain why they limit the spacing X to be around 2 meter or 1.5 or 1.25 to 2 meter.
Yeah.
Because if you increase this spacing, you need bigger section, and the Berlin is not that strong to carry more load like rafter. Okay.
And how do you get 6 purlin? Did you just assume? Or?
That's just assumption. Just assumption. I will tell you two methods to get the number of spacing, but I will work similar to the example.
Yeah.
So you can get it. Now, if you have like this arrangement for our shed, you can assume it is we have 6 spacing, like the example, and then if this assumption is wrong, so you can assume more or less.
Yeah.
Like if I assume this 6, this means we have how many distance we have, because we have 2 at the edges, so we have 5 distance, 5 spacing, right?
Yeah.
3x. This 3 internal, so 3x plus 7.75 from right, 0.75 from left, so we have 1.5x.
Yeah.
Okay, so this 9 meter should be divided to 3x plus 1.5x, right?
Yeah.
So 4.5x should be equal to 9. That gives us that x is equal to 2 meter, right?
Yeah.
And this is the internal spacing, internal, and the external spacing according to our assumption is 0.75x, which is 1.5 meter, right?
Yeah.
This is our external spacing. Okay. And these two values, the internal and external spacing, are in the range. So our assumption is okay.
In the range. Oh, yep, is in the range. Yep, yep.
Yeah, the range you said is from 1.25
Yep.
to 2 meter, right? So our assumption is good or fair in the range given to you by the course, right?
Yep.
Okay, so this one way to assume the spacing. Your problem only why the R6 or 5 is spacing, not more or not less, right?
Yeah. So there's because in the lecture side, you know, when you got 4.5, so 9 divided by 4.5, John added one more to the internal. Like instead of dividing it by 4.5, he divided by 5.5.
Yeah, but here you see here we have 3 internal and 2 at the edges, but the other one maybe we have 4 in internal and 2 at the edges.
The other one had 3 internal and 2 of the edge, so it's the same.
Really, I checked I have answered a question on the forum maybe yesterday or the day before, and I checked. I will check again, but do you understand it like this?
Yeah.
Okay,
So
so okay, if we can, I will save this one. The second, another way to do it, easy way. So if we have the same span like this, we have this as, let's say 9 as well. Okay. So you can assume x. You can assume x is 1.5, let's say, because you have two unknowns, so you need to assume one and get the other one. If I assume x, this I assume the spacing between this is just initial assumption, okay? Just assumption to start to know the Berlin spacing. Okay, so if x is 1.5, so how many number of Berlins we need? Do you know?
6.
Yeah, we divide 9 by 1.5. This gives us, we have 6 Berlins. Okay.
Yep.
So we have 6 Berlins, and we will have one at the edge and one at the other edge, and we have 4 in between, right?
Yep.
Okay. So now you know how many spacing we have according to the assumption. And now you know that we have x, 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 and here if you want to do it 1.75x and 1.75x. So according to this, you can know exactly how much x. So what is the, if we sum all of this, so we have 3x plus 1.5, so we have 4.5x, right?
Yeah.
And this 4.5x will equal to 9. So now we get x will be equal to 2 meters, and the external spacing will be 0.75x equal to 1.5. Okay, so the first step I do just to know how many Berlins I need. So according to this number, you can get the exact x or the actual x.
Yep. Gotcha.
You get it, or you want me to explain more?
Yeah, I think I got it. Thank you.
No problem. There is nothing wrong or correct in this one. You just need to arrange the Berlins according to the limit they give to you, like 1.25 to 2. So you
there's
need,
no right or
yeah.
wrong.
Yeah, so if I put 6 and you put 5, doesn't matter. If we are all engineering, one else you can put 8. If you put 8, it will be like, instead of 2, it will be like 1.4.
Okay.
All of us are correct. But when we design Berlins, if I take x as 2 meters, it will be different from x is to 1.4. Because if you put 1.4, this means the load for each Berlin will be small.
Yeah.
So you use a smaller section. If you increase the spacing, you will have more loads and you will have bigger section.
Gotcha. Thank you.
Okay, no worries.
I'm just you on that. What?
Okay.
Sorry. Why is the Yeah, you just explained, but I didn't get it. Why the external spacing
Yeah.
is less than the internal spacing? Again.
Okay, this is just assumption. You can use all of them similar, but because the course material are like this, so we are doing like this. Why? I will tell you why now. Because you remember last session when we say the column on the edge carry less load compared to the column at the center.
Yes, because it's less
This area.
tributary area. Yeah.
This area. Similar if we have this plan and this our Berlin according to the arrangement. So the red is the Berlins. Sorry, my drawing is not good. Okay. So this is the arrangement and the red lines are Berlins. Okay. And
Yep.
as you can see, this is the spacings between each of them. Each spacing, each Berlin carry half from right. This is like called area method or approximate calculation method. Okay. That each member should carry the area, half of area from left side and half of area from right side. Okay.
Yeah.
So this Berlin carry all of this area. Do you know how much is this area? How can we calculate this area?
It's just internal spacing.
Yeah, if this x and this x, so this will be half from right, half from left, so this will be x. And in the other direction, this is the span, which is S or L, whatever. So this area is x multiplied by L, right?
Yep.
Similarly, all the internals will be same, right? This one. Is there any difference? All of them carry a spacing, an internal spacing. Okay, except for this one. This purlin to the edge, what is the area it carry from the slab or from the roof? This area, the black area, right?
Yeah.
Okay. What is this area? How much is this area?
It's half of the external
Yeah.
span.
Half. Because it is at the edge, so it carry half. So this area is 0.5x multiplied by L, right? So what do you think? The edge one carry less than the edge one carry less than the internal one, so that's why we assume small spacing at the edge. Okay. Do you get this? This is just assumption, not you can assume all of them X.
Yeah. Yeah, because I'm thinking, because it has less area.
It should be
the reverse. It should be more.
It should be more. Yeah.
Can go. Yeah, can carry actually a little bit more. If I'm using the same purling size.
Yeah. Anyway, the edge spacing, maybe because also it will get some something from the girts or any other stuff will support by purlin, because at the top of the wall maybe the girts transfer some load to the purlins.
Yeah, and there might be
and also from wind
load. Yeah,
the area to the wind has also some yeah. It is only not only from the purlin arrangement, but also it may carry some other load from other load cases or other wind load or earthquakes, but we are not dealing with in this course, so that's why maybe the reason is not very clear to you.
Yeah. I have also another question with the video. So what should we put in the video?
Okay, the video should be, I will stop sharing this one. Okay, what do you need to put in the video? You need to put your work in the report. Like it is like a presentation to show the main point of your research. And yeah, like a brief description for the shed, and maybe what is this it and what is the parameters you have, like the wind area or yeah, like wind zone and this stuff, and also what you have done in the design of rafter and column, and that's it. You need to put also conclusion in your video. So you go through the report, like you summarize what you have done in the report in this video.
Okay, so just a summarization of the report. That's all. We don't have to have a specific focus.
Yeah, it is just a presentation, but because we are doing online course, so you will not be presenting on the marker, so you will prepare video for the presentation. That's what it means for us. So you have understand what you have done, and that's it, and you show others a summary of what you have done, like introduction and body of the presentation, which is the design parameters of your shed and the section you have select, and that's it. But you don't have to put all your calculation again in the presentation, because for the presentation you don't put all the details, just a summary of what you have done.
Okay. Yeah. Thank you.
No worries. Okay, we return back to Kyle. Do you still have any question, Kyle?
Yes. When calculating the dead loads for the actual building, or the shed, sorry, I don't know if I'm going in the wrong process. I'm looking at the dead loads first. So I'm looking at the sheeting, the purlins, the beams, and the columns. Do we have to design the beam first before we know what the actual mass of the beam is to include in the dead weight? Or is there a section in the 1170.1 which gives us conservative kilonewton per meter square cube?
No, you have to assume a beam first and then go through the loading and get the moment if the loading or the moment is sufficient, the section you select is sufficient for the moment you have. So that's it. Otherwise, you will need to select another section.
So we have to design the beam first, and then once that the design's been done, we will then have a value, or we'll have a type of beam that'll be used. A
No, but
classification.
you will not be able to design the beam without the dead load. So, like you have already get the Berlin and you assume one Berlin, right?
Mm-hmm.
So you have the on weight of the Berlin, on weight of the sheets, insulation, sealing, everything. So you now can calculate the dead load of for the rafter, right? But you will miss only one thing is the on weight of the beam or the rafter.
That's correct.
So you have to assume that you have, let's say, universal beam size 310 or whatever section you would select. And this one you have on weight from the tables, one steel tables. So now you know the on weight of the section, right?
Okay.
And summing this to the on weight from all the other elements like sheet, roof sheet, and Berlin, and so on. So now you have dead load for rafter, and then you have life load for rafter. Then you have wind load on rafters. Then you can do the combination, load combination, and you select the higher or the critical combination positive, critical load negative, and now you have M positive maximum, M negative maximum. Okay. With these two moments, you will check the tables or the graphs for the section capacity. If the section capacity satisfy M positive and M negative, so the selected UB 310 is okay, right? If the section capacity is less than the moment you have, this means the section you are using is unsafe, or the section you assumed is unsafe, right? So you need to select a bigger section or use a fly bracing.
Okay. Yep.
Okay, and that's it. You don't worry about the dead load in the next step, or but at the first step, you need to assume a section to get a on weight of it, and then use it to design the beam. Otherwise, you cannot go through.
Okay, no, that's fine. I think so obviously I was going back to front. I was trying to calculate the dead load before the design of the beam, which is incorrect. So that clarifies it.
Okay, that's good. So you get it now?
Yes, I do. So, yep, I'll sort the beam out first, and then once that's done, then we can work out the dead load based on the type of beam that's been selected.
Yeah, it's just because we are designing, so you are assuming at the start, and then you check your assumption at the end. If the assumption is okay, so the section is okay. If not, so you need to select a bigger one.
Yep. Okay.
And also, Lynn have a message to you. She checked the lecture notes, and the section note has typo. It is 4.5x instead of 5.5x. Maybe that's make you confused. For David, sorry. This for David. David will ask this, right?
Yeah.
Okay.
Just on that, I did some calculations in Excel, and I ended up getting the value, the correct, well, don't know if it's correct or not, but following the actual notes, I reverse calculated in Excel and I got the correct values. So I'm not too sure if it is a typo or not. Are you able to have a look at it and confirm that, Amit?
Okay, I will have a look. Okay, can you share the screen for me? Because I will take time to, if you have the
Yep. Okay. Just
yeah,
give me
yeah.
2
I give
seconds.
you permission to. Okay. Any of you has other question now?
Just coming up now. Just hang on a second.
Okay, we finish this first and then we can move forward.
Yeah, I think the dead load calculation goes first, isn't it? You assume a section of the beam, the rafter, and then calculate everything from top to the rafter. That's
Yes.
the
Yes,
dead
this
load.
is the concept of design. You need to have a fair initial assumption for the section first to use it in your design, and then calculate all the load depending on this section.
Yep.
Oh,
Okay, I have a look now.
Can see your screen, Carl. See the 5.5? It's a typo there. It's actually 4.5. When you divide you're using 8 and divide by 4.5, it's actually getting back to 1.78 meter. So
Okay,
all
you
the
can-
way through.
You can check it. He said that the total number of x will be 4.5, and then in the equation he said 8 divided by 5.5, which is
Yes.
Yeah, that
Wait,
one is a
oh,
typo.
and even on
Okay.
the graph, you have only 3x and like 3 internal spacing and 2 at the ends.
Yes,
So
that's
it
what-
is just error, typing error.
That's why I was getting confused with the that's why
Yeah.
I asked you, I mean, in the course form. I thought I was going crazy.
Yeah, you're right. But it is
Yeah,
just
I spent like an hour just doing. I'm like, it's not adding up, and then now you explain it to me. It makes sense.
Yep.
yeah. You can have, if you have something like this, you can post on the forum and we'll
Yeah.
try to help, because sometimes this is written by human, so you can find errors. That's
Yeah, for sure.
very common.
Yeah.
Okay, thank you for sharing, Kyle.
Okay. Perfect. No worries.
And my explanation was, if you don't get it how to assume an initial number of Berlin, you just divide the span you have by 2 or by whatever spacing you assume, and then get a number of Berlin, and then you reversely get the actual spacing. Okay.
Yep.
Do you have any other questions?
I'm good for now.
Okay, that's good. Thanks, Kyle. David, do you have question?
I'm good. Yeah.
Camel is mute today.
Hello, yes. I understand what you're talking about there, a little bit like, the exterior purlins, the spacing, the number of purlins involved in the.
Yeah.
But my question is a little bit in the beginning, like, we got 1170.1 to choose. And we got the AS 4055 that we are compatible with, that the design of the shed with all criterias, like is within parameters, like we can choose from that. Otherwise we have to go to 1170.2. But
Yes.
I can't find specification of the shed. Like the shed is, what is it? Is it because in the 1170.1 it says like seating, like minimum vehicle traffic area, or where to choose it from, warehousing and storage area. I found it very difficult to choose my shed. Or like, I don't want to make a mistake. Area susceptible to overcrowding is not that one. Area with possible physical activity is not that one. Area with fixed seats is not that one. Area with
Because you don't have like very detailed
No, we don't.
Yeah, for this shed. But if you are designing, you will know exactly what is this shed used for, and what is the type of like whatever you said, crowd or the use as storage or whatever. So you will know exactly the details, and you can use depending on that. But because you are doing a specific project, and this project is a simple project, so just to give you that, it is a domestic shed. So domestic shed is under housing, so you can use the 45-55 standard for wind. This standard
Yeah.
is for housing, because house or sheds are limited height, 1 story, like 3-4 meters. So
yes.
yeah.
So
So,
yes, but the specific type of activity, occupancy of part of the building or structure, it doesn't matter that one, because you know, I know
yeah,
you
yeah,
said
because if you need a parameter to choose depending on it, so it will be given to you. But because the assignment didn't mention, so this means that you don't need it. You know what I mean? If there is a thing
Doesn't
you need
matter.
yeah, it doesn't matter, because for housing it doesn't matter. For the housing code or housing standard, it doesn't matter.
But there is a, before you saying that, like, you know, to work the load is not really important to do it first. You have to do the purling first, or you calculate that, and then from that you are going to calculate the dead load for after calculating the purling. Like, you know, the weight of that is going to be involved. Then
yeah, because
that
if
it?
you have a look on the examples, or if you calculate it yourself, the dead load, the on weight of this rafter or this purlin is almost neglected compared to the other loads, live load or wind load. You know,
live load, wind load, yes, because we got
yes.
specific, like, you know, criteria. We got some parameters to work with the wind load, but live load, nothing. There is no live load in there.
Yeah, no live load, because it is nobody will get on the top of the shed.
Yeah,
Normally,
it's
only for covering, not for usage.
yeah.
Only minimum live load to maybe wipe the water of rain or something like that, or cleaning, something like this. Only one
So
person.
it's all assumptions. I know it's all assumptions, but for example, my assumption is going to be very different than other people's assumptions. So is that, it doesn't matter? Or do we have to come up with the
If
same?
you use the parameters for wind, all of you will get like if you are in 6 wind, let's say, so you will all get same pressure of wind, and then you get same pressure of same.
No, I'm not talking about wind. Wind is very easy. Like I'm
wind,
talking about
have
the dead load, the dead load of this structure, the permanent load of this structure.
Yeah, the permanent load. What is the permanent load? You mean the selected because every one of you has different parameters. So every one of you has different values of load. Like me, if this assignment is generated randomly, so you cannot find anyone like you.
With the given like, you know,
yeah, like parameters. Different span, different wind area, different everything is different height of columns.
Yeah. Okay.
So the design is not only one answer is correct. That's why this project is has variations in but you should do a realistic design or logic design.
Well, the first question is how, you know, the load, dead load, and horizontal and vertical load. The first question, whatever, you know, the horizontal and vertical load, and that's where I'm stuck, because horizontal and vertical load is the dead load. Like, there is no other load in there. Vertical load is just dead load, and from dead load we have to know
how to get out of this cycle now. If you don't have the beam, you cannot design. So you need to assume a beam to design.
All right. Yeah.
Right.
Now it's very, very clear now. Thank you.
Yeah. Any design will be like this. If you have different or several parameters unknown, you should assume 3 or 4, and then keep one only unknown for you to get Otherwise, you will stay here forever, you know.
Exactly. Yeah. Yeah.
You
Great.
should assume a beam, and then after getting through all the calculation, you can judge. But if you are, because this is the first project you are doing, or the first example you try, but after designing, you know, the shed has a range of section to be used as Berlin, as rafter, as column.
Mm.
You know, if I am working in industry and I every day I design a shed, or I involve it in construction of shed, so I know how, if this area wind class in 5 in 2, the sections will be 1 2 3.
Yes.
So after design, after experience, you can assume a good section at the start, and then start calculation. This is how design go. Like the first assumption depends on your experience, and then you go through calculation using the standard and the course material. You find it very easy. And it is not wrong. You assume something, and at the check of moment you get the section unsafe, and you increase the section. This is not wrong. This is just assumption. So no assumption is wrong, as long as you correct the design at the end.
Yes, I did. Now it's clear that we need to calculate first the weight of those purlins and calculate all these
Yeah.
like, you know, given stuff to just find out the structure weight. So it is convincing. It is. Thank you. Like, you know, this Zoom meeting is very, very important. Without it, I will be sitting forever thinking that I'm going to do the dead load first. And
Thank you.
yeah, great.
And you don't have to worry about, because it is better to assume rather than neglect the own weight. Another option is to calculate all the loads without dead load or own weight. If you design like this, so your design may be incorrect, or the structure fails because you neglect one of the loads. But if you assume, at least you have some load in the own weight area or
Accounted
whatever.
for.
Yeah, you accounted it in your design.
Yeah, great. Thank you
So,
very much.
Yeah, no worries, Cam. Thank you. Okay, Len, do you have any other question?
Not really for this week, but for the column, I might just ask next week.
Okay, so you delay this to next week.
Yeah.
I mean, for the assignment, if we follow just the slide for week 8 and week 9, we should be all right? In terms of most of the stuff should be in there, and also in the ASM.
Yeah. All the project is application of the course material.
Okay, cool.
And maybe a few things, maybe you don't get it from the material. That's why you are here. But nothing new you will do in the project or the assignment.
Yeah. That's it. Thank you.
No
Just
worries.
8 and 9, not 5 and 6, 7.
You may mean the column, maybe, because 8 and 9 are columns.
All right.
Beams-
But all the slides are, you need all the slides in your project.
Yeah.
Because you have layout of Berlin's, this in the of the bracing, this also in the slides, calculation of load the first week, wind load the second week, design of rafter and column in the 3 weeks in the middle, and final week you have introduction of concrete.
Yeah.
And that's it. Okay, thank you, David. Kyle, do you still have any other question, guys?
No, I'm all good.
Thanks, Kyle.
Thank you.
Thanks.
More good as well. Thank you.
Thanks, Len. Okay, all good now?
Yeah.
Camel, David, all good?
Thank you. Thank you
you.
very much. Yeah, all good. Thank you.
Okay, thank you, guys. I have recorded this session, and I will upload it to the forum again today.
Nice. thank
Excellent.
you.
Thanks, man. Have a good night. Bye.
You too, guys. See you
See you,
guys.
everyone. Bye.
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 Thank you.
Bye all. Bye.